I'm Philip Kruijmrink and I'm fascinated by the natural and socio-economic importance of the Asian water towers. I'm curious about the effects of climate change and socio-economic development on the entire system.
The Asian water towers are vast water reserves on the Tibetan Plateau and in its surrounding high mountain ranges. How does a team in the Netherlands at Utrecht University fit into this expansive, dynamic place? Maybe you can explain, Philip.
Certainly, our team at Utrecht University uses computer models to better understand both physical processes, like snow and glacier melt, and socio-economic processes, like population and economic growth. We've partnered with Professor Tandung Yao of the Institute of Tibetan Plateau Research to predict what these processes could mean for the future of the region.
Climate change and human development will define the future of the region. The people living here depend on the water coming down from the mountains. So, understanding future changes to water supply is crucial, right, Philip?
Yes, indeed. We're asking, how does climate change affect the ice reserves, and what does that mean for the amount of river water in the future?
Philip's group combines climate records from the past 40 years with climate change predictions for the next 100 years to understand how the supply of water that is stored in ice and snow will change. Philip's research will help us understand the cryosphere in this region. For us non-climate scientists, cryosphere is a fancy word. For what exactly, Philip?
Cryosphere refers to the part of the Earth system where frozen water occurs. You can imagine that climatic changes such as temperature rise or precipitation changes to have a strong impact on the state of the cryosphere. Would you like to see the models we're using?
Yes, please. Let's see how predicting the future cryosphere is done, shall we?
Well, we're using various models, some of which are state-of-the-art and scaled to large river basins. We're also using more specific models to understand cryosphere components in detail, such as glaciers or snow. And finally, models to understand socio-economic developments that affect water demand. Linking them all together allows us to paint the full picture.
That's pretty cool, Philip, but how accurate are your models? Can we really rely on them to predict the future?
The short answer is yes, but of course with everything there are limits. We try to incorporate all important processes into our models in order to achieve realistic outcomes.
Once the modelling work is done, what do you think will be the main outcomes of this project, Philip?
Well, by combining the different studies of the project, we determine the impacts of changes in water resources on sustainable socio-economic development. This allows us to predict how water resources will change and how affected people and economies might have to manage these changes in decades to come.
So far, one of the most surprising things Philip has found relates to seasonal snow. Although retreating glaciers are a benchmark of climate change around the world, he has shown snow to be much more important. Also, he has learned snowmelt is more sensitive than glaciers to climate change. There will be changes in seasonal water availability, which is important for cropland irrigation. People will inevitably have to adapt. Right, Philip?
Well, that's one of the reasons this work is so compelling, to understand how changes to these complex systems will affect many people, and how we, as a global community, can better prepare. That is also why I enjoy working with satellite images and models. They help me to make large-scale predictions that can have real-world consequences.